And hello guys, welcome back to our OpenFoam discussion. It's been a really long discussion trying to debug this heat transfer coefficient, but it is what we are doing. So in the last video, we were talking about the plume here getting mixed up because it's there is this mixing effect over here. There is somewhat of a the plume here gets mixed because of the big mesh size. So what we want to do is probably to change the mesh size. So you can see there is a plume here. If we use the custom scaling and we use 320 Kelvin, you can see that over here the plume is hot, about 320 Kelvin. But once it gets to the large mesh size, this 320 Kelvin thing is gone. You can take a look closer. Over here is 320 Kelvin, but once you see that the mesh size is smaller, this just disappears. And then it's like this plume has gotten stuck here. Okay. So this plume has gotten stuck there, so to speak. And that's problematic. So you can see the temperatures. Yeah, okay, this is like the end bit already. Yeah, at t equals 100 seconds, you can see that over here, because of the mesh along the boundaries of the mesh, you can see this phenomena actually happening, and that's not good. Okay, so yeah, probably what we want to do is, instead of having this, we want to have our whole mesh refinement over here in this area, preferably on the top. So there are a few ways we can do with mesh refinement. Now we can either get this whole case, we can make this whole thing add so many layers so that the whole mesh here will be in this kind of a circular layer format. Okay, that's one. Or we can use a refinement box over here to go from here, around this region. Okay, I'll use this snipping tool. So around this region over here is where I can do this refinement box, so that the mesh over here is finer, so that you won't have that kind of phenomena happening here, the mixing phenomena. Now I'd like to opt for the layer addition. Of course, that may increase the computational time a lot, but it does make for a very nice mesh and accurate results. Okay, so for now we want to do accuracy, not speed yet. So you just want the most accurate mesh. So I'm going to go with that. Okay, so let's try a few options of remeshing this thing. Okay, so I'm going to clean up the experimental case. I'll clean the experimental case, and here I save and quit. Okay, snappy layer addition. I'll clean here. Okay, and what I want to do is I wanted to go to the snappyHexMesh dictionary. System snappyHexMesh dictionary, and okay, I want to have maybe, let's say, 100 layers. Okay, 100 layers. Okay, 100 layers. We'll have 100 layers. So the outermost layer. Okay, the outermost layer, I suspect, may be one of these cells. This cell is actually 2 times the size of this cell. Okay, so so this cell here, the first cell, the cell number 1, is twice the size of cell number 2. And we want to have the mesh such that we have this similar length the similar what do you call that? We want a cell structure such that we have a similar thickness of the first few boundary layers. Okay, similar thickness, or maybe we can afford to be a little thicker. So we have cell number 2, which maybe the thickness is A. All right, and we have a mesh expansion ratio. Okay, this is mesh calculations. So let's say we have a cell number 2, thickness is A, and then the first layer is equals to 1.3 times to the power of 10. Okay, so this is 1.3 times. Remember we have 10 layers, right? So this is number 2 is the same thickness as the 10th layer, and this will be equals to 1.3 to the power of 10, because we have 10 layers, about 13 or 14 times as thick as the first layer. So this is 1 time. So if we were to change this and we'll invert it, the first layer will actually be about 0.07 7% of the 10th layer. Okay, so let's say we have an expansion ratio here. All right, and the 100th layer is accordingly a length of 2, and the first layer will be this length. Okay, it will be the length of, let's say, it will be equal to this divided by the expansion ratio to the power of 100, because we have about 100 layers. That's a good estimate. So 1.01, for example, it will give you the first layer, the size of 0.73. 1.02, it will give you 2.76, 0.276. So you want the first layer around this order of magnitude level of thickness, 1.03. And that will give you about 10. So expansion ratio of 1.03 with what do you call that? 10 layers, 100 layers should give you the desired results. So we have our itosphere, and we'll just do expansion ratio. I'll just use override the global settings here. So this expansion ratio will be 1.03 or 1.03. That will be enough. So let's do an all run serial pre, and we do in the background, and snappyHexMesh will get our layers conformed. And yeah, it looks like there is some problem that came about. So let's take a look at what problems there are in meshing this case. Let's go to snappyHexMesh, clear. So yeah, let's go to log snappyHexMesh. Okay. And you can run check mesh to see whether the mesh is okay. So it failed one mesh check. What is the mesh check that failed? Overall main bounding box okay. Mesh has 3 geometric directions, not empty directions. Openness okay, okay. Number of severely non-orthogonal faces okay. Alright, so this is just, I'm just checking the mesh of this. right, max skewness is that error in face pyramids. Yeah, 6 faces are incorrectly oriented. Okay, so yeah, the incorrectly oriented faces may or may not result in this thing called it may not result in a failed, the mesh instability that we are talking about. So let's see the sphere foam, see whether I got even the right snappyHexMesh dictionary. Okay, so let's take a look. I'll delete all of this and just F5 this. Okay, it doesn't even look as if the mesh is being generated properly. Okay, but let's try the slice, apply, and the slice filter should be a surface with edges. Ah, okay. It's very interesting. Okay. So the thing is that when we add layers to that extent, okay, this is very funny. Yeah, when you add layers to that extent, that you can't add any more layers, basically. All right. So yeah, we have this layer addition problem thing. So you can see this mesh is severely distorted out of shape. So that's probably not the way to do it. Okay, so we'll try something less extreme. Maybe we try 20 layers, all right? So I'm going to have a last layer here. Number of layers. Let's try 20, something a little more gentle. So it's not to give OpenFoam that crazy kind of thing that happens. 1.1, 1.2, okay, 1.25. 20 layers with 1.25. We can try that. Okay, 20 layers with 1.25. Let's redo this mesh. Hopefully, the snappyHexMesh does give the correct size now. Okay, so sphere.foam should be correctly reloaded. Let's go look at ParaView again. Okay. Looks like the slice plot isn't showing the right thing. It's as if the layer addition didn't even work. Okay. Okay, I'm going to set it back. Okay, so maybe I'll just do a, probably looks like a bug here, but I'm going to set it back at 10 and 1.3 expansion ratio. Okay, and let's try again. Shift F5. Ah, okay. So this is the original mesh that is the correct one. Okay, so this is the original mesh. I think, yeah, if we have too many, we can add a few more layers, of course. But it doesn't seem to be giving us the correct geometry. So anyway, previously we got the funny shape mesh, but this was the one that was working. So yeah, probably it's not a good idea to use the layer addition to make the mesh, you know, a circular kind of a shape. It's probably not the best of ideas, as well, it wasn't meant to do that in the first place. So instead of this, I mean, we can use something a little more less crazy. Maybe we just use 1.0 1.1, and we just do a end surface layers of 15. Okay, so I'm going to see the all run serial pre, seeing how we are going to use the meshing so often, and we're going to experiment with snappyHexMesh. I'm just going to do all clean over here so that it's easier to run. Okay, so what I can do is do an all run serial pre. And yeah, as we finish that, we can take a look at the sphere slice. What do you call it? The sphere geometry. Oopsie. This is the original block. Okay, we try again. Okay, let me delete. Apparently our sphere isn't resolving the things properly. Let's take a look. Log snappyHexMesh. Oh, okay. Looks like I forgot a semicolon. Okay, VI system. snappyHexMesh dictionary. Ah, yes, I forgot a semicolon after my expansion ratio. Okay, so we'll do the all run serial pre again. And while it's waiting, I'll just upload this onto GitHub. Okay. Okay, so it's gonna add to GitHub. I'm just gonna run a commit snappyHexMesh layer addition case update. Okay, and while that is going, I'll just reload this and you'll see the sphere here. And here's a slice plot. Slice plot will change to surface with edges, so they can see what the thing looks like. And this is what the sphere looks like, the mesh. Now obviously we want the top half here, the top of like this box, the top half. Let's see, let me use yeah, so we basically want to refine whatever this bit is, right? So yeah, we see that the mesh is pretty nice up to this point, and at this point we need to refine it a lot. Now the problem is we don't have any other geometry around, so we'll need to define a region with which to do this what do you call that, refinement. Okay, so we use this thing called refinement regions. Okay, refinement regions is here. Okay, and you are given the option to use a geometry, for example a box. So you will need to define a new geometry first. For example, inside this geometry here. So instead of using a surface mesh or something, we can use this thing called a searchable box. Okay, we can use a searchable box, and this will actually define a box for you. So it's a refinement. We can call it a refinement box, and there are many kinds of things you can do with this. Okay, so we can do a surface with gaps, and okay, all of this. Okay, all of these are just your options for refinement. So you can have cylinder, you can have box, you have a cone. Well, probably what we want is something of the shape of a cylinder, though a box will do just as well. You can even do a collection here. Okay, probably to let you have a kind of custom shape, where you can create some kind of overlap between like two surfaces or two shapes, and then you kind of add them together, you get this kind of a thing. So that's what you can do. Okay, so these are just some of the options, and if you want to explore more, you can see the Wolf Dynamics what do you call that again, the Wolf Dynamics PDF or PowerPoint on snappyHexMesh. They have lots of goodies down there. Very good for you to check it out. I'm just going to go straight for a searchable box or a searchable cylinder to start with my geometry. So I'll use cylinder first, and all you have to do is to define the upper and lower point of the cylinder. So point 1 and point 2 are the axis, and we will just, the 3D coordinates of the axis. Alright, so where about do we want our axis? So if we take a look here, we see that the center of the sphere is 0, 0, 0. So we'll just increase the y by, let's say, okay, give or take, let's see, maybe we can use a scale or something like that. Where's the scale? Maybe I use this. Data access grid. Okay, now it's lagging. Okay, good. So use a data access grid to get the scaling out. So about 0.03, y equals 0.03. That's where we want to start refining our cylinder. We have a cylinder, or that helps to refine all of these things here. So that's the z-axis. It's 0, and the y-axis you should start at about 0.03. So we can use that for refining. Okay, so 0.03, the radius, we can give it 0.03 radius. Okay, because this whole thing is spherical, it's about 0.03. This about here, the radius, the radius from here to here, from here, the center to here, is about 0.03, because the length of y from here to here is about 0.03 meters. Okay, so 0.03 is a perfectly fine radius to go with, so we can go with that. Okay, so I'll clear. I can do a git push over here, and just let it push while I start dealing with this using the left hand terminal. Okay, so let me go system snappyHexMesh dictionary. First thing I want to do is to add that searchable cylinder into the geometry. Okay, so I'll use the term refinement cylinder. So what is this? A cylinder. Okay, refinement cylinder. 1, 2, 3, 4. Open. 1, 2, 3, 4. Close. Okay, close here. Save. I'll write it. So I'll give it a type, searchable cylinder. Okay, searchable cylinder, point 1. Yeah, I'll just use a tab here to make it more consistent. Point 1 will be, okay, point 1 will be having an X and Z value. Okay, let's see, searchable cylinder, X and Z value of 0 and Y value of 0.03, X and Z value of 0. So do we need a semicolon? Yes. Point 2, X and Z value of 0 again. Okay, so 0.5 will be the maximum. Okay, 0.1 will be the top of the cylinder. Okay, so from here 0.03 to 0.1, that's the axis of the cylinder, so I'm just going to add that in. Now 0.5, 0.0, close, and the last entry we want, or I want, will be this radius. Radius will be 0.03, and I'll put a semicolon there to finish it off, and then I will add, okay, this is a searchable cylinder, then I will add inside the layer addition or cancellation and refinement. That will be the place I put it. I find it, and I'll look for refinement regions. Okay, refinement regions will be here. All right, so the refinement regions will be refinement cylinder, which I just defined the name. Yeah, refinement cylinder is the name. Okay, refinement cylinder, that will be the name of it. So I'll look for region wise refinement. So I will change the box to cylinder. Okay, so I'll start to remove the comments. And next thing I want to take a look at is the mode. The mode should be inside. So what it means is that everything inside the refinement cylinder, that will be the what do you call that? Yeah, everything inside will be refined. Okay, everything inside of the refinement cylinder will be refined to the level that you specify. So the first entry in this levels will be the distance, okay? Because okay, this is how the levels thing is defined. Okay, so for example, if we use the inside mode, everything inside will be refinement. If we use the outside mode, everything outside will be refined. If we use this distance, so the first entry is the distance from the surface. Okay, so let's say this is your surface, and let me zoom in. Let's say this is your surface, your first, and this is okay outside, and this is inside. There will need to be a certain distance from the surface which you refine. You refine it here. So that is your first entry. Your first entry is the distance entry here. If let's say you were to do that, and that's the distance it's talking about. And of course, if you were to use the distance and mode of refinement, you also need to define an inside distance, for which within this zone you start to refine. So let's say you have a box. Okay, so everywhere where you define this distance, this part will be refined. If you define this distance to be, let's say, the inside distance, the inside. And when you define the inside, you will do it here. Okay. I mean, okay, sorry. It is not, you don't define the distance in and out separately, but you define, you define the distance as such. If let's say it's 1 meter, okay, so 1 meter is your first entry, and then within 1 meter it refines to a level 4. So that's how you put these entries. Okay, and if you're using the distance mode of refinement, you can again specify more than one level. You can define another level of refinement so that within 2 meters of this this box, in both inside and outside, you refine up to a level 3. However, for the inside and outside modes, the first entry here, it's ignored, so you don't have to care what it is. You only need to care what the refinement level is. In this case, this refinement level is 4, so it gets it's 4. Yeah, so we don't want a level 4. Maybe a level 2 or 3 will be sufficient. So I'll just give it a level 3, and I'll save and quit, and I'll git add this to track the file. Okay, I will do an all run 0 pre, and I'll put an N. Okay, so that should hopefully give us the right mesh. Okay, now it looks as if there's something wrong because this thing is not being refined at all. So let's take a look at the snappyHexMesh. To see if there's any kind of error. So it's currently running. Okay. So it takes a lot of iterations to do it. Yeah. So it looks like it's taking a lot of iterations. So we'll need to give it some time. Okay, so it's 1366 lines now, and then it can go on. Yeah, it's still running, so it will probably take some time. And after that, we want to indeed test to see whether this these layers can give us the desired results. So okay, so now it's doing change dictionary, meaning to say that this thing should be working. And the snappyHexMesh is complete. So we'll load the new mesh, and voila, it looks as if we do have a very fine mesh up there, a very cylindrical fine mesh. In fact, it's very so fine, I think we probably overdid it. Okay, this is a really fine mesh. Okay. Wow. Okay, so probably we want maybe a level 2. I think level 3 is overkill. It's gonna eat up lots of computation time. Yeah, and maybe we want to make the level lower. Okay, maybe towards 0.01 or 0.015. Okay, and yeah, 0.015, because you see that the mesh here still is not refined, though everything above it is refined, which is great. So let's just do that. We give it a little more space to refine, and we do a level 2 snappyHexMesh dictionary. So we'll give it a level 2 because level 3 is overkill. Alright, and okay, the point 1 should not be 0.03. Maybe we put it at 0.015, and let's see what happens. I'll run serial pre n. So okay, this is the way we do it. Okay, looks like the new mesh is ready, so I'll just put F5 to reload. Okay, looks like it didn't refine at all. Okay, looks like it didn't refine at all. So yeah, there seems to be some problem. Maybe we set the length too low and too close to these layers. That's why maybe there's some error. Let's do a 0.018 for example, and see what happens. Okay, or we can look at the log, the snappyHexMesh, to see if there are any clues as to why this thing is happening. Yeah, let's take a look at the system snappyHexMesh dictionary. Instead of 0.15, oh yeah, we did 0.15. It should be 0.015. Okay, I made a mistake there. That explains a lot. Or run serial pre n. Okay, now let me git end just to prep it for launch. Split mesh regions, change dictionary. Okay, that means it's about there. Shift F5. Alright, okay, so this is the mesh we roughly want. I know there's some funny shapes over here, but this should actually give us the results we want for the convection plume, because the meshes here are pretty nicely resolved. So yeah, we can do that. You can actually even get the mesh here lower to conform to this pattern, but actually we don't need that. Yeah, so we can do a commit here. Mesh refined for convection, so it doesn't get stuck. Okay, git push origin master, and alright, so this is good. So probably we want to start running this thing. Snappy layer add experimental case. And what we want to do is we just want to run a CHT multi-region foam. So that in the next video, yeah, this one is after the change dictionary, and we take a look at all run serial to see what else we need to do. You just do a run application, get application. So let me do a run serial. Okay, oopsie. Quit all, and we do a run serial, and to run CHT multi-region foam. Okay, so that will start running CHT multi-region foam. So in the next video we can discuss the results to see what the heat transfer coefficient is like. Hopefully this was helpful, although it's a bit long, but at least we got the mesh that we want. Okay, over here you see that the layers are boundary layers pretty well resolved, and everything above the cylinder in terms of y coordinates, these are adequately refined. So hopefully there won't be this mixing phenomena that happens as a result of coarse mesh. Alright, so thanks guys. I'll see you next time. We'll discuss more results. See you.